Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of optimization word problems. When you're given a word problem that asks you to optimize something, in other words maximize or minimize, you'll be given enough information to come up with two equations. One will be your main equation in which you're trying to optimize it. Okay, and it'll have two variables usually, and you'll need to eliminate one and then prove it's a max or min. How do we eliminate one of the variables? We use what is called the constraint. And the constraint is the equation that relates both variables to each other and allows you to eliminate one variable from the main equation. So solve for one variable in the constraint, plug it into the main equation. You'll be able to recognize your constraint because it'll be equal to a number, whereas the main equation will be equal to f of x or f of y. Actually, when you first start out, probably f of xy, but then you'll change it to f of x or f of y. So what are the steps? Well, this is what I recommend you do. First, read the problem once without writing anything down. You just want to get a rough idea of what's happening. Then reread the problem and write down all the given information. Be sure and clearly define the variables. X equals the width of the rectangle, or whatever the case may be. Draw a diagram that is clearly labeled. Then you come up with the two equations, the main equation and the constraint. That's step 3. Step 4, you're going to solve for one of the variables in the constraint and plug it into the main equation. Then we're to the max-min stuff that you should already be familiar with if you've done max-min problems, given equations. That's all you do. Either do the first derivative test, where you take the first derivative and set it equal to 0 and get your critical points, and plug in a test point to the left and the right of it, that critical point proving it's a max or min. Or you can do the absolute extreme method by finding your endpoints and then plugging these endpoints and your critical point into the original function, seeing which one has the largest or smallest answer. Now we'll go through both of these in a separate video, so whichever method your teacher prefers you can do. Alright? I hope I've eliminated any doubts you might have over the concept of optimization word problems. Make sure you check out the example videos. Seeing it done clears it up quite a bit. More importantly, try to do some on your own. Practice, practice, practice. As always, thank you and have a nice day.